I'm sure you can name all the planets in our solar system, but can you name them in correct order from the Sun going out to the last one? If not, by the time you've watched these next 4 episodes of Our Night Sky, you'll be able to do that, plus you'll also have learned all the latest information there is about our solar system and the planets that belong to it. We're going to start with Mercury and Venus. I'm Brett Bailey, and this is Our Night Sky. Well, our first planet today is going to be Mercury. That's the closest to the Sun at about 57.9 million kilometers away, or 0.39 astronomical units. Now, you remember what an astronomical unit is. It's the distance that astronomers have developed for measuring distances within our solar system. And 1 astronomical unit is the distance between the Sun and the Earth. So the distance from the Earth to the Sun is roughly 115 million kilometers. So if we were standing on Mercury's surface, the biggest thing we would see would of course be the Sun. It would appear 3 times larger than what we normally see it here on Earth. Even at that distance, it still takes the sunlight 3.8 minutes to get there. A planetary year on Mercury is 88 days, and 1 day to night cycle is an unbelievable 175.97 Earth days. So an Earth day on Mercury is longer than an Earth year. And you're going to see that happen again with Venus. Mercury is a terrestrial planet, just like Earth and Venus and Mars. And the fact that it's got an inner core, it's got an outer core, it has a mantle, and then there's a crust that covers the whole planet. The core is believed to make up about 42% of the total volume of Mercury, but it has cooled off quite a bit. And in doing that, it's kind of collapsed upon itself, and it's wrinkled the outer crust. The planet itself has a consistency of about 70% iron and 30% silica materials. When did we first start noticing it? The Sumerians made note of it in 3000 BCE. The Assyrians, sometimes later, they noted it in 1400 BCE. But in more modern times, Copernicus noticed it in the 16th century, but Galileo was the first one to actually observe it. It's been known to exist for a good long time. But Mercury is a shy planet. And it's shy in the sense that we can't often observe it because it's so close to the Sun. In the daylight, it's obscured by the bright sunlight. So the best chance we would have is when the Sun has just set, and if the planet Mercury is in the right position of its orbit, we'll be able to get a good glimpse of it as it sets down over the western horizon. Failing that, the next opportunity we would have would be some hours later when the Sun comes back and rises. If Mercury's in the proper position again, we'll be able to see it just before the Sun breaks the horizon, maybe a little bit afterwards until the Sun gets way too bright for us to look in that direction. So in that sense, it's a little bit of a shy planet. Now the Mariner 5 probe was the first one to bring back lots of good information about Mercury. One of the surprising things is that its magnetic field is 100 times weaker than that of the Earth. And this might be because of its rotation. Very, very long rotation in the course of its 2 years nearly. And as a result of lacking magnetic field, it wouldn't be able to protect the surface of Mercury from the solar winds and solar energies that are coming off the Sun. Now the next planet we're going to talk about is Venus. It's the second planet from the Sun after Mercury, and it's 108 million miles away from the Sun, or 0.72 astronomical units. It takes sunlight 6 minutes to reach Venus. The problem with Venus, its atmosphere is made up of 96% carbon dioxide and about 4% nitrogen. Carbon dioxide, as you know, is a greenhouse gas. And as a result of that atmosphere of greenhouse gas, the temperature on Venus is about 527 degrees Celsius, way more hot than the required temperature for melting lead. The pressure of the atmosphere is also extremely high. It runs from between 75 to 100 Earth atmospheres, or 1,087 psi, up to as high as 1,400 psi. There's no chance of anybody surviving on that. As well as that, other hazards in the atmosphere include a high-level layer of sulfuric acid clouds. And they say that when it rains sulfuric acid and snows metal snowflakes. So it's not a good atmosphere to be trying to survive in. In fact, early Russian probes visiting Venus didn't last any more than just a few hours because the pressure and the high temperature just basically killed their devices. Now, Venus is the third largest planet of the minor planets. It's about 95% the size of Earth, so it's very, very close to Earth's size, but much more inhospitable than Earth is. So our next planets that we'll be talking about in the next episode will be Earth and Mars, and I'm going to try to get those up in the next few days. And we'll talk more about the magnetic field that covers or surrounds a planet such as Earth. One thing that's helping Venus is the ionosphere. Upper layers of the atmosphere is protecting the planet from absorbing too much solar radiation. So that's it for these two planets, Mercury and Venus. So that's it for these two planets, Mercury and Venus. Hopefully in the next few days we'll have another one up discussing Earth and Mars. So by that time you'll have half of the chain of planets in order: Mercury, Venus, Earth, and Mars. And with Earth, those four, it's the one that has the greatest magnetic field around it. And we'll talk about how that formed and what it does to protect the Earth. So until then, thank you for watching, and support Our Night Sky by subscribing. And in the meantime, be safe, look out to those around you, and on a clear night, look up and just enjoy our night sky.